I want to take you down a path of some work that I've been doing for the last 2 years with Kellogg School of Management, in particular with Mohan Sawhney from Kellogg. My name is Oliver Ratzesberger. I'm Senior Vice President of Software Development at Teradata, where we write a lot of that software at scale. I spent 7 years at eBay, worked with Nahum in particular on some very interesting and challenging data science problems. And in my line of business, I talk a lot with CIOs and C-level executives. And when you do that, it's all about capabilities and maturities. It's about what kind of capabilities do companies have to develop to compete in the market, to do more with data, right? Yes, some companies like eBay and Google and whatnot have tens, hundreds of petabytes, even exabytes of information. CERN, certainly, as we heard, right? Huge amounts of data. And then there's a lot of companies that have terabytes, maybe hundreds of terabytes, maybe even a few petabytes. And over the last several years, I started realizing it's less about the amount of data that you have, of course, right? It's really what you do with it, right? And what are the capabilities that you need to build? And I want to take you through a little journey here, something that we call the Sentient Enterprise, that we have developed that is kind of a maturity model for companies of how to get really advanced with data. And I'm not going to talk about technologies, I'm not going to talk about products, not about what algorithms you need to use, but what kind of the capabilities are that companies are building out there. Before I do that, and that's just a little bit to point out where we are in technology and what the times are, right? This gentleman's name is Robert Ney. A few years ago, he wrote a game for the iPhone, right? High schooler, got to 400,000 downloads on the first day, put Angry Birds to the #2 spot. More importantly, he spent less than 30 days writing that game off of an open source package, the Corona SDK, that he downloaded for free from the internet and reached hundreds of thousands of people in a single day. If you think about that, what we have done to technology and what we have created is really that concept of platforms that allow people with very little understanding of all the technologies that are in there really build next generation capabilities on top of that. It's really, I think, a sign of times of how fast things are moving when nowadays even high schoolers can create software and mass deploy that. Because the other part of what we do with data is also, try to roll out some changes, try to install something, right? We usually aren't very good at cloud and DevOps to begin with, but high schoolers are, right? And so what do we need to do to enable companies? Two particular trends I want to highlight really quick here, of course. We live in a real-time world. Everything is real-time around us. I remember when I'm a born Austrian, I moved to California in 1999. When I opened my Wells Fargo checking account, I got a monthly statement, right? And in between, I kept checks. I wrote down what I spent, right? Nowadays, it would be completely unacceptable if I couldn't pull up my smartphone and look in real time what it is, whether it's sports scores, whether it is travel, whether it is news. Everything is happening in real time around us. Yet, when you look inside of companies, right, everything is batch. Everything takes a long time. Everything that gets processed once a day, once a week. Now, there's a lot more real time coming in, but not pervasive yet, right? There's very few companies out there that are really good at doing that at real time. The other part that goes hand in hand with real time is what we call self-service everything, right? I mean, it was okay a few years ago to go inside a bank to do business, right? I even want to avoid the ATM today if I can, right? If I get a check, I'll take a photo with the smartphone, right, and get that uploaded. If I have the choice, I will avoid calling any call center if you give me an app or a website that I can go to, right? And again, if you look at that, and if you look at most IT organizations, how do we work? We work with tickets, right? Open a ticket to get something done. And one of my favorite examples was a couple of years ago, we had to move some new data in, and it took us months for whatever reason to do this. And when we did the root cause analysis after that, we had 138 tickets to move a couple tables of data. Why? Well, the first set of tickets that we opened, somebody decided they were incomplete, so they were closed after 7 days. Open new ones, right? Oh, you need to traverse some firewalls, open more tickets, right? Oh, this is some data from there, you need some tickets, right? IT organizations, when it comes to real-time and when it comes to self-service, we really struggle with that. And that's a problem when you combine that now with data and when you combine that with low latency. And we had some questions before, right? How much time do you have to wait for an answer? You don't, right? You want to be agile, you want to move fast. And so what that leads in a lot of companies is typical data anarchy, right? Silos and silos of data. Don't even know where the data exists, right? Have no idea who to ask for that data. We use a lot of human beings to actually sift through data. As Nahum said before, right? 80% or more of our time we spend finding the data or identifying it, right? Not acting on it, right? We use human beings to copy data around, right? We call it ETL and whatever we want to call it. It's like copies of copies of copies of data, right? And ultimately, all of that leads to a lot of fire drills in organizations that really push down on productivity in what could be done with data. And yes, years ago, we all came up with this wonderful, let's build a data warehouse, right? And we stick all the data in there, and all is good. Yet, we did it with a very typical software development lifecycle, right? We started with a threaded requirements document, right? Fill something out, we'll give you some data, right? The problem is, in many cases, we really don't even know what the data is that we want, and so filling something out, describing what we want becomes really difficult. And quickly, you get into more companies where everything takes 18 months or 2 years or 3 years to get anything integrated. And of course, everybody's running away from that as fast as they can. And enough executives in companies have money in their pockets to buy themselves whatever, right? And again, doesn't matter what technologies this is. File systems, Hadoop, different databases, SQL, NoSQL, SQL++. It doesn't matter what the technology is. This is all done for agility. I have a problem to solve. I have 30 days to come up with something, 90 days, right? I cannot wait for somebody to give me something in 18 months because by then, next year is around and the business has changed and I need to deliver something, right? The problem with, obviously, what happens with that is, and we saw that before, the data chaos or anarchy, now you have all of a sudden 2 executives meet in a boardroom, and I've been sitting in these boardroom meetings where executives at the C-level have argued who has the right data, right? No, we had 4.5 million active customers in Q1. No, it was 7.5 million. And what Wall Street saw was the average of the 2 numbers, right? Because that was the best we could come up with. Real problem, and we started over time. It was actually some of the work that Nahum led for us. We started quantifying some of these things. We gave them a name. We called it data drift. And we said, you know what? Data drift is a real problem. And by the way, when you put big data onto something that has already this problem, the problem gets exponentially worse. It gets worse and worse, and all of a sudden, you create more silos. And yes, you might have 2,000 node clusters of Hadoop that all are copies and copies of data, and all of a sudden, your data marts are petabyte systems, right? A real problem in a lot of companies. So this is where we said we need to do something. We need to give companies kind of a maturity model to say, how would you go about that if you were to do this right? And we're calling it the Sentient Enterprise. Sentient for all non-native English speakers here, right? To be self-aware, human beings are sentient, right? We thought of it as think of it as what Six Sigma is to quality. We wanted to give a North Star of dealing with data, in particular with big data, right, out there. What do we need to do? How do we become successful with that? And here's the 5 stages. And we call the first thing the Agile Data Platform, where we say, first, you need to get agile. If you can't get agile with data at small scale, it gets a lot harder with big data. I hear a lot of people running around saying, big data, we do big data, therefore we are agile. It's the opposite usually, right? It quickly turns into wild, wild west when you just have all of a sudden 26 million files on a large cluster, right? And all of a sudden, nobody in the company knows anymore where these files are from. That's not agile, right? That's a real problem, right? So what are some of the things that we did over the years? We said, obviously, this mess of copies of data is something that we need to avoid. We can't survive this. We can't live in this environment. And one of the first things we said, well, we need to bring self-service and real-time self-service governance into this into this world. And the way we went about that is we built a concept that we called virtual data marts. And nowadays we're calling them sandboxes, or we're calling them, prototyping environments. The point is, give me a self-service web page cloud infrastructure where I can self-provision myself a sandbox. And by the way, we started that small. I think 2005, the first sandboxes we gave out were 200 gigabytes. I think nowadays, at eBay, probably the largest ones are 100 terabytes, 200 terabytes sandboxes, right? That somebody can self-provision on the spot, right? Now, you don't give everybody that size of a playground, but the idea was we needed to create something that somebody can have total self-control, work in a really agile environment, self-provision this in 5 minutes or less, pull any data in that they need to do, but have access to all the data that the company already has somewhere out there without having to make a copy. And at first we were like, well, let's build databases in the cloud or NoSQL or whatever systems in the cloud. The problem we quickly started realizing is if we do that, go to Amazon, provision right now whatever system that you want, right? And turn it on and log in. What do you see there? You see nothing, right? There's no data in it. So what's the first thing that you have to do? You have to copy data there. It's like, okay, that's not going to work, right? Because that's exactly the problem we are trying to avoid, these copies of data. So we said we need to build an infrastructure ourselves that, yes, you get an empty space, but through that empty space, you see all the data that the company has. And that's how we built them, right? And that's how they are being used nowadays at companies like eBay by the thousands every day, by analysts, by single people, by small teams, by large teams to build next generation models, right? And do the algorithms that they need to do. We also started realizing that governance needs to go hand in hand with this, right? We had to build a fast path methodology that if somebody showed up with a prototype out of one of these sandboxes, how could we turn this into production very quickly? Because we didn't want to have them lingering around. In fact, we made them so that they would expire in 30, 60, or 90 days. And you would get an email, your sandbox is going away. Yes, you could extend it, but by the time you would have extended it like 2, 3, 4 times, you got on the top of the list of, we need to work with somebody here to see what they're really trying to do there, right? And so we built the fast path methodology. Ultimately, the goal was, let's get these things into production in 4 to 6 weeks. And we started learning that, a prototype done by a team in Agile, in Scrum or whatnot, was 100 times better than any requirements document that these teams would have ever written before. Because the requirements documents always started out with, give me all data in all possible combinations with all possible drill downs, because we have no idea where the insight sits, right? The other thing that we did is we developed ourselves a classification layer model for data. By the way, this has nothing to do with systems. You can do this on your iPhone if you want to, or on your computer, or on a complex infrastructure with SQL and NoSQL systems together. We started putting, and by the way, we derived it from the OSI 7-layer model. We said we need to do something similar for data. We need to do some classification where we can anchor ourselves and, by the way, decouple all of these processing. We're trying to do too many things at once. Whenever you copy data, you usually try to do this ETL. You take it, you massage it, you change it a little bit, you land it. And when something goes wrong at 2 o'clock in the morning, it's really difficult to figure out, was the copy that was wrong? Was the source system wrong? Was our algorithms wrong that ran on top of it? And we said, we need to decouple that and break that apart. And we came up with something like this. Very simple. Layer 0 is raw data. Raw data in its raw form, no transformation allowed. Data that goes in there should be unchanged. It should be just as it came from the source system. Having said that, that includes structure. If data is structured, don't throw away the structure, right? Too many times we made the mistake. We unloaded things from databases and threw it into flat files just so that everybody then would have to guess, like, oh, this looks like a date. I guess it's a date, right? That's already a breakage in lineage. When there is somebody who has put some structure on something, structure must survive that thing. It must go there. However, there's data that doesn't have structure, is semi-structured. Nowadays we see, of course, JSON and all these kinds of data formats in there. Integration layer, this is really where we started thinking about, now how do we integrate that data? In traditional warehousing, we would have done complete data models. Now, in big data, you can't model the world, right? There's just too much data out there. You need to focus on tightly coupled data, some data that you really understand well, that you want to get really productive very quickly. You integrate that well. And then there's loosely coupled data, right? Clickstream, for example, was an example for us because a day of Clickstream has between 60 to 100,000 unique tags in them. You don't model 60 to 100,000 tags. But as we were learning about the usage, we took some of the tags, like search impressions, like ad impressions, out and stuck them into a well-defined model, right? So integration layer is how do we get the keys together? How do we tightly, loosely, non-coupled data in the same spectrum? Then on top is the calculation layer. This is where models and KPIs got brought into the system, right? How do we calculate something? It needs to be in the platform. It needs to be version controlled because if people look at the raw data, don't have the calculation handy, right? They will make up the calculation, and more often than not, they will get it wrong compared to what the standard is. Aggregation layer, this is now roll up the billions and trillions of events into microsegments, into products, into algorithms, clusters, whatnot, right? And put on top of it a presentation layer that allows us to really make the data understandable to the various different user groups that need access to that. And all the way on top, the data labs, the sandboxes, as I discussed before, right? And if you look an overlay up on top, and it's not meant to scale, the vast majority of users gets to see the presentation layer, and just that, right? Thousands of users in your company, they get to see the presentation layer. Very simple structures, pre-calculated numbers, but they have also their data labs, and they can bring in other data. Business analysts, power users, they drill down more. Data scientists, we need the raw data. We need to see that raw data, right? But it's also dangerous territory. You don't want to open up that raw data to just everybody because people make really, really bad mistakes when you give them raw data too early, right? And so that was kind of our framework in between these data labs or virtual data marts and the layered data architecture. That's how we structured projects, right? To get them quickly in a 30, 60, 90-day period going and fast and ultimately put them in production very quickly. So first step is just about agility. It's kind of getting that balanced, decentralized use cases while still keeping the data as centralized as possible out there. Very simple, right? This might be the boring part. Now it gets interesting, of course. Second step for most companies is that shift from transactional to behavioral thinking, right? And we talk a lot about algorithms here and models, right? Of course, many of you, it's absolutely clear this is all about behaviors and all about clusters and all about patterns. When you talk to executives, they don't always get it right away, right? Their thinking is very transactional in their nature, right? How many products did we sell on Monday compared to last Monday, last month, last quarter, last year, right? It's way more important, however, to start thinking about what are the behavioral data points. And yes, the transactions are behavioral in themselves, but then all of a sudden there is the sensor data, there is the IoT data, there is the clickstream data that is all of a sudden interesting, and all the social media and everything else that comes in between. And all of a sudden we're no longer counting just transactions, we're looking at these patterns and behaviors, right? And again, all of you are experts in what that is. I'm not telling you anything new here. This is really about stitching together behaviors over time. And whether it is a retailer doing this for customer, or whether it is a Siemens or GE doing this for turbines or for locomotives, it's all about behaviors all of a sudden. Like, if you can predict the breakdown of a locomotive with a 95% certainty, 24 hours or longer, huge impact to the business model, right? And so what happens is all of a sudden, like, the organization starts creating behavioral thinking, right? For us back at eBay, it became apparent when all of a sudden the CEO had the #1 KPI on his list of 12 KPIs, Net Promoter Score. If you're not familiar with Net Promoter Score, it's take all the people that would promote you and would say go buy with them, they're really good. Subtract basically all the people that say never ever do business with them again because I really hate them, right? And when you looked at that Net Promoter Score in 2007, eBay's was probably in the low 60s. somebody like Amazon was in the high 80s, right? All of a sudden you start realizing we have a problem way beyond transactions, right? And all of a sudden the whole company started shifting towards behavioral thinking, and this is when experimentation platform became all of a sudden the big new theme. How do we make decisions around products, not by smart people, but by algorithms, by multivariate tests that we need to run, right? How do we change algorithms to better, to amplify good behaviors and eliminate bad behaviors out there? A big mind shift for a lot of companies to get executive level people start thinking in behaviors instead of Wall Street transactions, right? Which is very heavy thing. Now, if you do that, great. We are agile. We are now starting doing behavioral work. All of a sudden, you start realizing traditional search or metadata or catalogs or whatnot no longer work for the organization. Why? Because once you start putting people into the mix of all of this, so we're doing all of this agile work with our sandboxes, the organization absorbs more data, all this big data comes in, it also creates way more output, all of these behavioral models, right? All of a sudden, onboarding a new data scientist, 12 months, right, to get them somewhat productive, because they need to find out who the people are that have built all these other behavioral models within the company. And we started realizing that, metadata was no match for this thing. I mean, yes, we had a team of 5 or 10 people that did nothing but data modeling and metadata. We could have increased it by an order of magnitude, and we would not have kept up with the amount of turnover of new data that we would create. And so we said, we have a real problem here that we need to solve very differently. And this is where 2008, 2009, we started building the first incarnation of that. We called it the Data Hub. By the way, this is not a screenshot. This is just a simplified graphic for it. The idea was we needed a social collaboration platform, a LinkedIn for analytics, a crowdsourced infrastructure that allowed people to follow data, that allowed people to find what people are doing with this, to learn how other people are using this, to allow us to ultimately say, here's the data sources that people are combining, or here are the hottest trending data visualizations within the company. The ability to follow key analysts or data scientists within the company in their work to see what are they working on, to identify other data scientists within the company or other analysts that were working on similar problems so that you could actually start talking to them, right? A huge capability, and it's something that I think is much underestimated in a lot of companies. See a lot of startup companies, or some startup companies now finally coming up in that space, really focusing on how do we build graph and social on top of collaboration, because metadata doesn't scale. Because we need a search index for all of data and the values and the content and the descriptions that is meaningful and has relevance built into it, right? So ultimately, this is really turning to some extent, the Kaggle model that we heard before, right? Internally, right? How do we get people internally to work together, even run competitions, to collaborate, to search, to analyze and share. And ultimately, we made it so easy that if you saw, for example, any Tableau visualization or any R chart or whatnot, you could immediately, with a one-click, collect that in your profile, right? And by doing so, you would give us an indication that you were interested in that. And we would follow along who is using what and what people were doing. This stage really about collaboration. How do we bring people together through graph, through social means internally? Because by the time you have 5,000 or 10,000 people in an organization, it gets really hard to describe all that explosive growth of data and insights. Okay, great. All of this insight is great. We create more algorithms. We create more outputs. For many companies, the algorithm and that wonderful visualization is just a starting point to the real problem, right? Because sometimes I walk into companies and we see these wonderful wall arts of graphs and other visualizations of what they have found. And when I ask sometimes the teams, it's like, what have you done about that? And it's like, well, we we're thinking about what we're doing about it, right? Just identifying churn or fraud or whatever failure patterns is not good enough if you can't operationalize and do something about that. And this is where really an app platform comes in. This is where cloud has to meet big data at scale so that, you know, the high schoolers of the world can all of a sudden build something on top of a platform that is way beyond their scope. And yes, this is where we need to learn in big data from the platforms that you and everybody else here is so used to using every day, right? This is what made the smartphone a revolution, whether it's iPhone or whether it's Android, whatever your platform is, right? They have become successful because they have become app platforms, right? Hundreds of thousands of apps, not written by the makers of the phones, but by the rest of the world, right? Same thing, if you nowadays want to get the power of something like Google Maps onto your website or blog, what is it? 5 lines of JavaScript? You don't even need to know JavaScript. Copy and paste is what you need to know, right? And you can make that work. The power of platforms cannot be underestimated, and it's not there today in many companies when it's about data. It's always about, oh, there's data models, and then there's BI developers, and then there's data scientists. They don't meet together, and we have a hard time really putting output together. The other part about the app platform is this typical problem of, even if you do integrate some data, by the way, whether it's EDW or Hadoop or file system or NoSQL, doesn't matter. We send people, in many cases, towards source systems to get us data. Go extract that data, right? We have a lot of people asking for data, and then small teams in the companies that say, go extract the data out of there, right? The problem is they are not the ones that have created that data. They are not the ones that understand the data to begin with. They're usually looking at data and it's like, well, you told me it should look like this, but it looks very different. We need to change that model upside down. What we have built over the years is really something there's the inverse of that. We're calling it data listening. And data listening platform is really, how do we put data integration at scale at the fingertips of every developer, every data scientist within a company? And quite honestly, it's the model of any API-based platform, right? Go get yourself a self-service API key and then put in a one-liner in the top 20 programming languages, whether that is Python, Java, or whatever the language is, and start emitting your data. Nowadays, with RESTful services, with JSON data structures, and all the variants of that, right? This is something that needs to be done in a very different way. This needs to be done through self-service. This needs to be done through, let me establish new streams of data, whether that is clickstream, whether it's sensor data, Internet of Things. By the way, I'm completely with you with the comment before. Millions of codes of lines, right, for Internet of Things will never take off, right? But the good news is, with the right architecture, with something like Python, with like RESTful, with JSON, I mean, you can get thousands of sensor data sources for a typical home integrated with a few hundred lines of code, right? And now scale that up, right, with technology, and it gets really interesting. And then, so this is about just the apps platform. This is about how do we do data integration in real time at scale? How do we make the data stream within companies? And ultimately, the final goal of Sentient Enterprise is, we're calling it the autonomous decisioning platform. This is really algorithms at work, right? Today, as we said before, too much of people time within companies, even dealing with data, is done searching for data, sifting through data, right? There's companies that have built hundreds of models and KPIs and visualizations. They no longer have enough employees to look at every single one of these metrics, at every drill down, at every visualization every day, and so they miss all the trends that are happening under their nose with a technology that they have already built, right? This is really where we need to change from searching through data to decision making. And how do we do that? That's algorithms, right? This is algorithms at scale that is out there today, right? This is whether we look at algorithms of even some of your cars that have adaptive cruise control, right? The algorithm that checks 60 times a second the distance and the velocity of the vehicle in front of you, right, does not get distracted by the accident on the side of the road or whatever happened over there on the other side, right? Hits the brakes probably an order of magnitude faster than a human being can be, it's algorithms at play. We have been doing algorithms in many different areas. Automated trading is a good example, right? You cannot be successful in trading nowadays anymore if you're not on top of algorithms, right? And human beings are training algorithms. The problem is many companies are out there around the world aren't yet to the level of deploying algorithms at scale. I'm not talking about a fraud predictive algorithms. I'm not talking about optimize your search relevance or ad relevance. I'm talking about algorithms and signal detection at the enterprise scale that all of a sudden in the morning says, hey, Oliver, here are the top 3 trends that are different, right, in the company. Somebody should look at them, right? Start bubbling up the signals and trends from the noise out there. And there's some companies that obviously have made this really a goal and are working very actively on that. And the idea here is really to bring together the whole company much more as a single organism through data, in real time, through algorithms, at scale, right? Do it for thousands of data sources, for thousands or tens of thousands of matrices and models, and ultimately let people in real time get information pushed to them where they say, here is something I need to make a decision as a human being to drive that forward. And so with that, this is out of time here. We might have a couple of questions. So this is the 5 stages of what we call the Sentient Enterprise. Really a framework, not about what the individual technologies are, but what are the kind of capabilities are that companies need to build to become agile, to start thinking in behavioral terms rather than transactions, to do collaboration at scale through social and graph, right? To ultimately roll out application platforms themselves where anybody who finds insight in the data can encapsulate this in an app, whether it's 20 lines of Python code or a couple of 100 lines of something else. Deploy it, zero cost, like a cloud, with DevOps in mind. And enable that at scale so that we can put predictive technologies and algorithms really at work at scale within companies. So with that, we'll take a couple of questions.
Thank you. Thank you. That was an excellent helicopter view over the whole line. So let's open the floor for some clarification questions. Please identify yourself and the question.
Sure. My name's Justin Hyde. I work for Oracle. What about security? I mean, you talked about metadata catching up, but we need to keep at least security metadata. And the structured data is the data which often needs security being kept with it.
Yeah, very good. Security and privacy in general, right? I mean, this goes much further. Yeah, I didn't talk in this shortened version of it. Absolutely critical. If you can't get security right, then you can't be agile. And what we found whenever we tried being agile, if we didn't spend enough time up front on security and getting security right, security would either get in the way and would slow us down, right? Or by not doing it as good as we needed, we've started exposing things that we shouldn't, right? And so this whole agility, this whole concept of sandboxing, for example, is an interesting area. So when you talk about security, of course, we only let you put data in there that you have access rights to do so, right? But we also started realizing we need to do audits, for example, on these agile sandboxes, because as it turns out, once we started auditing them, all of a sudden, like, we found PII data, right, in a sandbox of somebody, where none of the members of the sandbox had any right to see PII data, right? And we were like, so how did that happen, right? How did PII data get into a sandbox if the 5 people that have access to the sandbox, none of them have access to PII data? And we traced it back, and interestingly enough, that PII data didn't even come from our existing system. It came from data uploads. It came from, a marketing department or whatnot did a study with an external company to ask 1,000 customers a couple of questions. They got in return an Excel spreadsheet. They uploaded the Excel spreadsheet, and the Excel spreadsheet has PII data in it. And we started realizing, oh my God, I mean, there is there's Excel spreadsheets running around within the company, of course, without any governance, right? Now, how do you deal with that at scale, right? This is an interesting problem. You can slap their fingers and say, hey, you had PII data. In all reality, all you do in that case, however, is like they're going to start hiding it from you. They say, okay, I can't use their sandbox. I need to get my own one because when I use theirs, they find out I'm doing something I shouldn't be doing. But it also speaks towards the amount of training and education you need to do within companies, because whatever policies and whatever checks and balances you put in place, right? If there's an Excel spreadsheet floating around that has data that it shouldn't have, that's a real problem, right, at scale to deal with.
Okay, thank you. Is there any other clarification question? If not, then I have a last question before the well-deserved coffee break, I think. It's an easy one, I think. You started out with a kid of 14 years old, having 400,000 downloads the first day of his app. That was your starting point. So here you end up. And now I end up with this glorious pathway from here to heaven. What did you learn from that kid? And what should that kid learn from this picture and in understandable words for him?
I think the biggest thing that we learned from the kid was actually probably in stage 4 in this whole application platform, because so many companies find insight in data, and I find so many visualizations coming out of algorithms and whatnot, and we look at them, we all get excited. And if you come back 6 months later and it's like, what have we done within the company about that? The answer usually is, more often than not, nothing, right? We sent an email to somebody, we recommended a change in business practices, nothing happened, right? And we started realizing the reason for that was quite often that just finding some insight in data, it's the first step. Implementing that into a real-time action that does something and do that at scale very quickly takes a platform. Because if you don't have a platform, it means go back to an overloaded team, stand in line, wait for 6 months until it's your turn before they implement something for you, right? This is where really it hit us. It's like you need to start turning big data into its own application platform to let less experienced people push out actions through a platform.
Excellent, but now what are you going to tell the kid?
What am I going to tell the kid? Write more apps?
Good.